Hi, in this video, we're going to talk about ICMPv6 address resolution. Resolution. So we've seen this before. I've talked about these two messages, the neighbor solicitation and neighbor advertisement messages used with address resolutions similar to ARP and IPv4. So we'll just take another look at them since they're part of ICMPv6 neighbor discovery. So address resolution. I know the IPv6 address, but I need to know the MAC address. So as we know let's take a look at how we do this. In IPv4, we use ARP, and in IPv6, we use ICMPv6 neighbor discovery. If we look at the differences in IPv4 compared to IPv6 with neighbor discovery, we'll see the destination MAC is a broadcast as compared to a multicast, and we'll see that's an advantage for IPv6. Because it is a multicast, it's going to use it's also going to use IPv6 multicast. We'll see how these interrelate. We've talked about that before. Because IPv6 uses solicited node multicast. Okay, and IPv4, as we can see, the ARP message is sent directly over Ethernet, where in IPv6 we use ICMPv6, a neighbor solicitation or neighbor advertisement message, which means it's carried over IPv6, and then that packet is carried over Ethernet. All right. Whoops, went too fast there. ICMPv6 solicited node multicast. So this is where the mapping comes in. It allows us to filter at the NIC. So if you take the IPv6 address you're looking for, this address right here, we take the last 24 bits of the interface ID, copy those to a solicited node multicast address, IPv6 address, just the last 24 bits. And then we copy these 32 bits to the IPv6 address. So it's really just the last 24 bits that get copied, but with the FF, it's part of the last 32 bits of the solicited node multicast address. Just a reminder, so when a device has any IPv6 address, unicast address, global unicast address, or link local address, that'll be mapped to a solicited node multicast address that gets mapped to a Ethernet NIC card. That means, or Ethernet MAC address, excuse me. That means the Ethernet NIC can filter on this address, determine whether or not it has an address that is associated with these last 24 bits. Okay, that's where this whole mapping comes in. That way it can use, that way devices sending messages to this device can use a multicast. All right, so what's the advantage of a multicast? In a broadcast, Ethernet broadcast, all the NICs have to accept the entire Ethernet frame and send it up to an upper layer process like an ARP process to determine if this message is for them or not. With multicast, the NIC card, because Ethernet multicast MAC address, the NIC card can make that determination whether or not it needs to send it up to another upper layer process for processing or further determination, or whether it can filter it itself. Most of the time, the NIC card can filter it and knows whether or not it's for it or not. I should say this another way. Most of the time, when the NIC card accepts the Ethernet frame, because it matches a MAC address, that maps to one of its IPv6 addresses. Most of the time, that upper layer protocol, the message is that the device is the intended target of the message. It is possible that another device can receive it and have the last 24 bits of the same address as this device, and its NIC will accept it, but an upper layer process will say, no, it's not for me when I look at the entire IPv6 address and not just the last 24 bits. Okay. So in IPv4, device uses ARP, knows it's PC1 has a packet to send PC2, knows its IPv4 address, not its MAC address, checks its ARP cache. If it's not in there, sends an ARP request. The device will send an ARP reply. It's, as we, excuse me, as we mentioned, the ARP message is sent over Ethernet, which is a broadcast. The ARP request is a broadcast. In IPv6, it knows the IPv6 address, but not the MAC address. It checks its neighbor cache, similar to an ARP cache or ARP table. It sends a neighbor solicitation message. The intended target sends back a neighbor advertisement message that gets added to the neighbor cache. And as we've just seen, that this is all sent over ICMPv6, which is sent over IPv6, which is sent over Ethernet. The neighbor solicitation message uses a multicast, which gets mapped to an Ethernet MAC multicast address. We'll see that more in a moment. Okay, so let's take a look here. Let's say this device here is going to send a neighbor solicitation message for the IPv6 address of PC2. Okay, it knows its IPv6 address, but not its MAC address. Okay, now this IPv6 address that it's trying to reach, this device will have a solicited node multicast address that maps to that address, which means this multicast address will map to this multicast address, the Ethernet MAC address. Or we'll have a MAC, I'm sorry, I thought I had it there. It'll have a 3333, see I can do this here, FF, and then it will have, oops, 0000, oops, yeah. Oops. There we go. All right, we'll see that in a moment. Oops. Okay, so here's the neighbor solicitation message. The source is link layer address. One of the options is source link layer address. We'll see that in a moment. Okay, let me just kind of bring this all up here. All right, so this is the entire neighbor solicitation message in the Ethernet frame. So I'm going to back out of this, and let's just take it piece by piece. Here's the ICMPv6 message. Okay, so the we see it's a neighbor solicitation message, type 135. This is the target address. So when it builds this ICMPv6 message, says, I'm looking for whoever has this IPv6 address. Now I'm also going to include my MAC address, so whoever responds with a neighbor advertisement message can send it directly to me. But I know I know this IPv6 address. I need to know the MAC address. Okay, so this gets encapsulated over IPv6. Okay, there's our next header field. Here's the source address of the neighbor solicitation message. Here's the destination address, and this is created from the target address, the address we're looking for. So notice that we're just looking here, okay, at the last 16 plus 4 plus 4. Okay, so 24 bits here is what we're mapping from here to here. Okay, this is going to get mapped to the last 24 bits of the multicast address. Actually, we say 32 bits here, but what gets carried over is 24 bits here, 24 bits here, 24 bits here. So anybody with these last 24 bits is going to, that NIC card will say, hey, this could be for me. Okay? It's just more efficient than a broadcast. That means not everybody has to accept this Ethernet frame. Okay. The neighbor advertisement. So here's the return response with PC2's MAC address. So of course it's going to include the target link layer option 2. So this is where it's going to say, look, I'm a neighbor advertisement message. This is the address you were looking for. That's my address. Right? So that's who you were looking for. You knew that IPv6 address. What you didn't know was this. Okay, this is my this is my Ethernet MAC address. And that's what you needed. And I include my IPv6 address because you might be sending out a neighbor solicitation message for more than one device. So, you know, when you see this MAC address here, it relates to this IPv6 address that you already knew. Okay. Sent over IPv6, next header field, okay, from this source. There's the source IPv6 address, which is this, same as the target address, okay, because it's this device. Okay, it's just saying, hey, this is my IPv6 address down here. Okay, and it's sending it directly back to whoever sent the neighbor solicitation message. Okay, and this is sent as a unicast. Remember, so it received this device's MAC address in the neighbor's solicitation message. That was included by the router in its neighbor solicitation message when it was looking for this IPv6 address. Okay. Duplicate address detection. So neighbor solicitation messages and neighbor advertisements are used to make sure when a device creates itself any unicast address, global unicast, link local, it doesn't matter whether it was dynamically from Slack, DHCPv6, or manually created. Although DAD, duplicate address detection, is recommended but not required, just about all operating systems do this. They want to make sure that before they use a unicast address, nobody else is using it. So what they do is they send out a neighbor solicitation message, basically saying, hey, who on this network, on this link, has this IPv6 address? Send me your MAC address. Of course, it's hoping nobody's going to respond. And it waits a few milliseconds, and if nobody responds, it says, great. If nobody responds, then this address is unique. It's for me, nobody else is using it. Now, it's only recommended because with interface IDs that are /64s, especially if you're using Slack or, especially if you're using Slack, most likely it's unique. 1 in 18, 18 quintillion possibilities out there, possible addresses. Where you might come into problems is if you start statically creating addresses. You might give two switches the same IPv6 address so you can access them remotely. And so this would be caught with duplicate address detection. Okay. Again, and you can see this process and all these processes with IPv6 and neighbor discovery with the debug IPv6 ND command. Okay, so that's ICMPv6 address resolution.